So today we'll classify triangles and classify quadrilaterals. First, let's define a couple of terms. Polygon. So a polygon is a closed shape made up of line segments. Line segments as its sides. Line segments as its sides. Yeah, so there's no curves in it, in a polygon. Now for a regular polygon, I got rid of the is, all the sides are congruent and all the angles are congruent. All sides congruent and all angles are congruent. And to annotate that, all the sides are congruent, you would have, let's say, a triangle like this. And notice these little like hash marks. See, there's one in there. That signifies that all the lines, the sides are the same. They're congruent. And over here, a four-sided figure. And again, all the sides are the same. And to say that all the angles are the same, I would just go ahead and put these little curves in here, these little arcs. That would signify that the angles are the same, and the same thing over here. Okay, so that's what a regular polygon is. The sides are the same length and the angles are the same. Okay, we have 6 different triangles, and the first 3 we're going to classify them by their angles. See there it says angles, angles, angles. And on the bottom one, these bottom 3, we're going to classify by the sides. See it says sides, sides, sides. All right, so kind of keep that in mind. There's different ways of naming triangles. Okay, this first one is what they call an acute triangle, because all the 3 angles inside, they are acute. They're less than 90. So it's an acute triangle because it has 3 acute angles. Next one is a right triangle. Why is that? Well, look, it has a right angle. It has one right angle. Therefore, it's a right triangle. And over here, notice that this angle right here, it's more than 90. Therefore, it's an obtuse triangle. And that's because it has one obtuse angle. Okay, so these 3 were by the angles. Now let's look at the sides of the next 3 triangles. Okay, this one here is called an equilateral. I'm not too sure if you have enough room to put all in there. Equilateral. It's equal. Lateral means sides. The sides are equal. Equilateral triangle. Why do you think they call it equilateral? Something about the congruent sides. There are 3 congruent sides. Therefore, it's called an equilateral triangle. Now, the next one, notice that there's only 2 sides that are the same. See these little marks right here? These 2? That means that these 2 sides are the same. It's not the same as this one that has a 1 line on it, 1 hash mark. And they call this an isosceles. Isosceles. The C is silent. Isosceles triangle. And it has at least blank congruent sides. Two congruent sides. It has at least 2 congruent sides. So the other one had 3. This one has 2. And this one over here, see, there isn't any, huh? And that word is scalene. Some pronounce it scalene. Scalene triangle. See that all the sides are different lengths. This has 1 mark, this has 3, this has 2. They're different sides lengths. So how many congruent sides does it have? Well, I'll say none or no congruent sides, or 0 congruent sides. Okay, so you just classified our triangles by the angles in them or by the sides in them. Okay, now let's go down to the bottom shapes here. If you notice, all of them have 4 sides. And the term we use for any 4-sided figure is quadrilateral. Quadrilateral. Quad meaning 4, lateral meaning sides. Quadrilateral. And all quadrilaterals have 4 sides. So notice that it kind of branches off though. We have this one over here, then going down to another 4-sided figure, then branching out to another one, yada yada. Okay, so there's a family of them. So let's go over to this one right here. Now I'm going to go ahead and put these little arrows on here to signify that these 2 sides are parallel with each other. And we call that a trapezoid. Trapezoid. And a trapezoid has exactly 1 pair of parallel sides. Remember, that's double L in the middle. Parallel sides. Just 1 pair of parallel sides. But it is 4-sided, so it is a quadrilateral. Okay, so that's this branch to the right. Now let's go down this other branch. Okay, and this shape is a parallel. I made a typo there too because it should be double L. Parallelogram. Parallelogram. And both pairs of opposite sides parallel. Double L in the middle. So we call it a parallelogram because it has 2 opposite sides that are parallel. 2 pairs that are parallel. So here's the thing. All parallelograms have 2 pairs of parallel sides. So that means this one here, this one, and this one, since they're all parallelograms, they have the opposite sides are parallel. And so I'm just going to go ahead and do those arrows right now. These 2 are parallel, and the other 2 are parallel. Same thing goes with this one. Top and bottom are parallel, and the 2 sides are parallel. Same thing over here. Like this one parallel. This one is parallel to this bottom here, this right bottom, and then these other 2 are parallel with each other. So again, all these 3 right here, well actually these 3 are part of the parallelograms. They're just special types of parallelograms, these 3. Now this one down here, this is a rectangle. So it's a type of parallelogram. And what makes it different, or what makes it a rectangle, is that it has right angles. Has 4 90-degree angles. And as a matter of fact, it's a parallelogram that has 4 And you could say 90-degree angles, or you could say right. 4 right angles. Okay, so that's this one here. Now let's kind of branch over this direction. Again, this one is a parallelogram. The opposite sides are parallel. And it's called a rhombus. R-H-O-M-B-U-S. A rhombus. Now granted, the opposite sides are parallel, just like the other ones are. But what's different about this one is all the sides are the same length. So I'll just put those little hash marks in there. So it has 4 congruent sides. 4 congruent sides. All the sides are the same length. Now the center one here is it's both a rectangle, it's another type of parallelogram, but it's both a rectangle and a rhombus. And that would be a square. And what makes a square unique is that the 4 sides are the same length. I'll just put my lines there. The 4 sides are the same, just like a rhombus. However, it also has 4 right angles, just like a rectangle. And it has 4 congruent sides. So it is a rectangle. It's just a special type of rectangle. It is a parallelogram. It's also a rhombus. It's a special type of rhombus. So if we just forget about this one on the side, these are all parallelograms, and this one over here is a trapezoid. Okay, example 1, classifying a triangle. Classify the triangle by its sides and angles. Okay, so the triangle has blank congruent sides. Blank congruent sides. Well, let's see, this is 6, that's 12, it doesn't have any. So it has no congruent sides. And it has 1 blank angle. Well, this angle right here. That's obtuse. So it has no congruent sides and 1 obtuse angle. Therefore, it is a scalene obtuse triangle. Example 2, classifying quadrilaterals. Name the types of quadrilaterals that have at least 1 pair of parallel sides. So all blank and blank have at least 1 pair of parallel sides. Well, let's see if we look at our picture. Again, here's a quadrilateral. We have this branch, parallelograms. They have 2 parallel sides. And then we have a trapezoid, which has 1 parallel side. These have 2, that has 1 pair. Trapezoid parallelogram. And they said, name the types of quadrilaterals that have at least 1 pair. Well, we know parallelograms do, because they have 2 pairs. Para and double L. Parallelograms and trapezoid, or trapezoids. They have at least 1 pair of parallel sides. Parallelograms include blank and blank. What do you think that is? Parallelograms include blank and blank. Well, if we look at parallelograms, remember, look at the two branches that come down. Rectangles and rhombus. Rectangle and rhombus. A square is actually both of them. So for a parallelogram, it breaks down into rectangles and rhombuses. So parallelograms include rectangles and rhombuses. So it looks like rhomb and buses at the end. And then rectangles. Okay, example 3, it says finding perimeter. A contractor is framing the wooden deck shown below in the shape of a regular dodecagon. Dodecagon has 12 sides. This is 12 sides. Write a formula to find the perimeter of the deck. Evaluate the formula for a side length of 3 feet. Okay, so the perimeter of the rectangle dodecagon is P equals da-da-da. In other words, each side has a length of x. See, it says let x equal the length of each side. So it's like having a whole bunch of x's here. Each side is that long. Therefore, so if the perimeter is adding up all those x's, then the formula for the perimeter is P equals 12 x's. 12 times x. So we write our formula, P equals 12x. We write the formula. Then what we're going to do for the x is we're going to substitute, let's see, it said here the side length of 3 feet. So we're going to put 3 for x. So I'm going to do that. I'm going to put 3 for x. And 12 times 3 is 36. So for a side length of 3 feet, the perimeter is 36 feet. Going all the way around is 36 feet. That's a perimeter. Okay, so observing this, looking at the sides of it, they all look a little different to me. All the sides look different. And then if I look at the angle, this looks like a right angle to me. So I'd have to say it's a scalene and right triangle. This is going by the sides. This is going by the angles. On letter B, you can see the two sides there are the same. And this angle right here, it looks like it's more than 90. So by the sides, I'd have to say it's an isosceles, because these two sides are the same. And then for the angles, I'd have to say obtuse. Letter 2, name the two types of quadrilaterals that have 4 right angles. So you can look at your diagram for that. And then number 3, write a formula to find the perimeter of a regular hexagon. Hexagon. How many sides is a hexagon? That is 6. 6 sides. So I'll just write that here. It's 6 sides. And then use a formula to find the perimeter if one side is 16 centimeters. So they name two types of quadrilaterals that have 4 right angles. That'd be a rectangle and a square. 4 right angles. Next one, write a formula to find the perimeter of a regular hexagon. Hexagon has 6 sides, so it's going to be P equals 6x. And so all I have to do is substitute. It says, what if one side is 16? So it's going to be 6 times 16. And if you multiply 6 times 16, I believe that's 96. So 96, and that is centimeters. Let me double check that. Yep, so it's 96.